Good morning. Today we're going to talk about the normal distribution. So this will be our last statistics topic. We'll talk about using the normal distribution and kind of making some um, decisions on the basis of kind of normally distributed data. Okay? So the first thing I want to talk about is what we mean when we say that data is normally distributed. So when you talk about the distribution of data, what you mean is kind of how it's arranged. So is it spread out very evenly, like everything is basically the same? We call that a uniform distribution. Is it all bunched up at one end or the other? We call those skewed distributions. But the one that we're most interested in is what's called the normal distribution. Okay? And so I've got an example right here of some data. So you can see I've got a frequency table. Value 0 has frequency 1, value 1 has frequency 3, value 2 has frequency 7, and so on and so forth. And I've graphed all of that data in a bar graph. And what you can see here is that the data is all kind of mostly in the center, that there's this big peak up in the center, and then it flattens out toward the sides. And so this is kind of your classic example of normally distributed data. So we call this a bell curve. So if you think about kind of what this shape looks like, you've got it's flattened out, it peaks up in the center, and then it flattens out again, and you get this kind of bell shape, right? So if you think about a classic drawing of a bell, this is data that is normally distributed, okay? So any data that fits a bell curve is normally distributed. Okay? And if you want to be mathematically precise, there's a lot more that you can say about going into this. How well does it fit a bell curve? Exactly what does it look like? That's not going to be the scope of this class. For this class, if the data looks like this, if it's got this peak up in the middle and then it flattens out at the sides, we're going to say that it's normally distributed. That's going to be good enough for us. Okay? So why are we interested in normally distributed data? Well, it turns out that a lot of things are normally distributed. So if you look at anything that is, and there's a lot of mathematics behind this statement, but if you look at anything that's impacted by a lot of different variables, the interactions of all those different variables together will give you a normal distribution. Okay, so what happens is kind of, so one example, and this is on the review sheet for exam 3, is about the weight of newborn babies. So the weight of newborn babies is normally distributed. And that's because the weight of a newborn baby depends on the mother's health, how long they were carried to term, the weight of their parents, the genetic heritage of their parents, the nutrition that they received while they were in the womb, all these different things, tons and tons and tons of different things. And so what happens is because all of them kind of pile together, it balances out and it gives you this normal curve, okay? So that's why we're interested in normally distributed data. Lots and lots of things are normally distributed. A couple features of normally distributed data. So first off, kind of this is the most important thing, is in general, if our data is normally distributed, the mean, the median, and the mode are going to be about the same. They may not be exactly the same, but mean is going to be approximately the same as the median, is going to be approximately the same as the mode. Okay? And so you can see in this data, your median and your mode are both 3. So if you count up, there are 4, 11, 23, 29, 31 different values here. So the 15th value will be the median, and that's a 3. Okay? So your median is 3, Your mode, your most frequent value, is 3. And if you calculate the mean using the frequencies, so 1 times 0 plus 3 times 1 plus 7 times 2 plus 12 times 3 plus 6 times 4 plus 2 times 5, all divided by 31, we get 317 plus 36 is 53, 77, 87 divided by 31. Okay, and 87 divided by 31, if we calculate that real quick, is 2.81. Okay, so the mean is 2.81, the median is 3, the mode is 3. They're pretty close together. Like I said, not exactly, but fairly close. Okay? So that's kind of ways to tell that something is normally distributed. Look to see if the mean, the median, and the mode are similar. Okay? Again, not the same, but similar. Look to see if it's got that bell-shaped curve whenever you graph the bar chart or the histogram. Okay? And that's going to tell you that it's normally distributed. What we're generally going to use with normally distributed, well, no, I'll save that for the next lecture. So in our next lecture, we're going to talk about z-scores and using z-scores to calculate percentiles, and then we'll talk about the empirical rule.